In complex electronic design, especially PCB designing, signal integrity and power integrity plays a vital role. If you are designing a complex embedded systems or maybe an IoT device, signal integrity is a vital information which you have to consider while designing the PCBs or routing the tracks on that particular PCB. So in this video, I'm going to talk about the introduction of signal integrity because it is a wide topic and very complex one which is not easy to cover in a single video. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. With my 8 years of experience in ESDM industry as a hardware design engineer, I'm going to consolidate that experience and talk about the signal integrity in this video. So let's get started. First thing first, let's start with what is signal integrity. Signal integrity is an ability of an electrical signal to maintain its quality and its accuracy from the source to the destination. For example, if we have one sensor which is analog in nature or which produces a signal in analog nature, then we have one microprocessor or a microcontroller. The ability of the output signal from this sensor to travel from the output pin of the sensor to the input pin of ADC at the microcontroller to maintain its accuracy and its quality without any distortion, that kind of a design in PCB is called signal integrity. Now you may ask, what is the importance of signal integrity when it is just a copper track from one point to another point? However, we can see the continuity by using a continuity tester. That's not what it is. It is more than that when it comes to the microelectronic signal or maybe the high-speed signal. In case of same example where we have one sensor with the analog output and also we have a microcontroller with the analog input as ADC input, on that time, assume that this sensor produces the signal or the output signal at a very low level like millivolts. On that time, if it is traveling from this point to that point in that particular PCB, because of whatsoever reason, if it gets disturbed by even 0.5 or 1 millivolt, that will change a lot of things or a lot of decision in microcontroller. That's why signal integrity is very essential, especially when you're working with the minute electronic circuits or maybe a high-speed design. Now let's talk about the 3 common issues observed on the printed circuit board or maybe the electronic circuits when having a poor signal integrity. The meaning of poor signal integrity is all about the electrical signal is incapable of maintaining its quality and accuracy throughout its transition. The first thing is crosstalk. Second thing is electromagnetic interference, and the third one is timing skew. The detailed video on these topics will come in the next sessions, but right now I'll touch upon them just for your understanding. First one is crosstalk. Let us assume we have 2 parallel tracks which are having a very good signal with respect to minute electronic signals. On that time, one signal will introduce a problem or disturbance in a neighboring track even without having a physical connection. On that time, it is called crosstalk. For example, RX-TX pin with respect to UART communication, I2C peripheral communication with a SDA and SCL pin. In such cases, signal integrity is very essential. If we are not having a proper signal integrity, these signals will not act properly and do not transfer the signal to the destination where they have to be traveled. Second common issue is all about electromagnetic interference. For example, you have one electromagnetic inductive component which is like inductor or relay or so many other components which emits the EMI. In that case, if it is interfering with respect to the nearby signal on the PCB, even though they are not having any physical connection, then it is called electromagnetic interference. Such thing will damage the entire performance of the circuit in case of it is a high-speed design or maybe the very sensitive track which is drawn near to those EMI components. The third one is timing skew. It is a little bit complex topic to understand for a beginners, but I try my level best with an example to explain to you. Let us assume that you have one source of the signal, but this particular signal has to be given to the 2 different components at a different place. On that time, you split that particular signal and connect to that particular components independently. The arrival time of this particular signal from the same source to the two different destinations, the difference in time to arrive to those two destinations is called timing skew. It is very essential in case of high-speed design, especially with respect to clock signal. If both the clocks are arriving to the destination of those peripheral in a different time means difference in millisecond or maybe microsecond or even nanosecond, that cause a lot of difference with respect to microelectronics. That particular difference is called timing skew. This is very essential to take care in case of high-speed design and high-density designs. Again, depends on what type of a design you are doing and what type of a component you are routing. That matters a lot in such cases. These are the three main reasons or three issues which can be observed on the PCB when it is having a poor signal integrity. Now let me know if you have experienced such kind of issues with respect to poor signal integrity in your design engineering in comment section. I am very happy to know about your story, and if possible, if it is necessary, I will address your issues in case of any questions. Thank you so much for watching this video on Introductory to Signal Integrity. A lot of topics related to advanced PCB designing coming to our channel Linked Frequency. That's why subscribe to us and share it with your learning buddy and help us to grow in the engineering community. See you again in the next video. Until then, tune yourself to make a difference.